Okay, so good day, good afternoon, good morning, everyone. So I shall continue today with the second part of the lipid. Okay, yesterday we have gone through the nomenclature. Okay, the way the lipid is being named. Okay, through the number of carbon. Okay, and also the location of the double bond. Location of the double bond. You have to see. Okay, yang attendance tu nanti lagi saya on balik. Okay. Okay, tadi cakap pasal apa? Nomenclature. Okay, you have to see because lipid chain dia ada the COOH part, okay, and dia ada the methyl part, methyl part CH3, okay. So you have to see before you name the lipid, okay. You have to see which carbon you start with, okay. If you start from the COOH, then you will have to decide. You will have to put the delta, the location of the double bond. But if you start from the methyl group, the CH3 group, then you put the number of the carbon where the location of the double bond, that there will be the omega. Okay, omega kat situ. Alright, so you kena tengok kat mana location, where do you start the naming of your double bond tu. Okay, the one that the fatty acid, okay, that doesn't have the double bond is much easier lah kan, it's much easier. Okay, and then you have to know the difference between the aliphatic yang straight line tu dengan yang conjugated one, non-conjugated and conjugated. Apa beza conjugated dengan conjugated? Lepas tu different types of fats lah. Okay, alright, so we have done that yesterday. So today we will go through the reaction and the factors that will affect the physical characteristics of fats and oil. Okay, so yesterday when we talk about lipid, we know that there are two physical appearance of lipid. One is oil, one is the solid. So you have to know the difference. Why some lipids are in the form of oil and why some lipid are in the form of fat or solid. Okay, kena tengok dia punya melting point also. Kan? Tengok melting point, and there are factors that we have gone through yesterday. There are factors that contribute to the melting point. Right? Alright. And then the factors that will affect dia punya characteristic of fats and oil ni include the degree of unsaturation. Kan? We talk about how unsaturated versus saturated. Kalau dia saturated, mostly they are solid at room temperature. But if it is mono unsaturated or poly, especially poly unsaturated, poly means you have more than one double bond. Okay, then most likely, okay, the physical appearance of the lipid will be in terms of oil lah, at room temperature. So dia bukan solid. Okay, and then length of carbon chain. So the higher the carbon chain, the higher the melting point will be. So nanti tengok what are the melting point. You can predict melting point. Kalau it is higher at room temperature, that means it is solid lah. Okay, and then isomeric form of fatty acid. Dia ada isomeric form. Ada molecular configuration and type of extent of processing. Type of extent of processing ni dia adalah physical one of the factors in food processing lah, that how the companies or manufacturers will modify in terms of processing punya parameters. Macam mana, how they want to do it, the type of processing and the extent. Extent tu maksudnya dari segi duration, dari segi how high the heat that they will give, or dari segi how much of the halogenation that they will give. Okay, these all will affect the characteristic, physical and chemical characteristic of the lipids lah. Okay, for example, liquid versus solid, the melting point, solidification, iodine value, that contribute to the final quality attributes. Okay. For the unsaturated versus saturated fatty acid, okay. So for unsaturated fatty acid, we know that it is liquid at room temperature, refrigerated, and also stored frozen. Okay, this one ada juga yang unsaturated fatty acid, dia tak follow this kind of rule. Okay, for example, linseed oil. Okay, dia bukan ni at room temperature lah. Okay, refrigerated and also frozen storage. And also for the melting point, they increase with chain length, positional isomerism, and also trans isomerism. For example, oleic acid versus ellagic acid. Kalau dia nak compare, especially this is a very good example of comparison between cis and trans isomer. Normally kita akan guna oleic acid versus ellagic acid lah. Okay, and also conjugation tadi, conjugation yang alternate double bond dengan single bond. Okay, and also for the unsaturated fatty acid, the melting point, the MP decrease with the number of double bond and also esterification of the acid group. Okay, of the acid group. For the saturated fatty acid, okay, they are solid at room temperature. Okay, but these are exception. Dia ada exception. Contoh coconut oil. Okay, coconut oil dia tak it doesn't show as solid at room temperature. Bila kita tengok coconut oil, it is a liquid. Oil is a liquid lah. Okay. Although it is saturated fatty acid. Okay. Saturated fatty acid also has higher melting point, and mostly it has more than 10 carbon chain length. Okay, or more than 10 carbons lah. So if more than 10 carbons, the melting point will increase. Okay. Tadi we talk about oleic versus ellagic acids. I think I have some pictures later out. I can show you. Okay, in the next slide. Okay, the packaging of fatty acid. Okay, the trans configuration higher higher MP than cis. Maksudnya kalau dia punya trans configuration tu versus cis configuration kan, kalau cis dia both the H group, H function group, they're located at the same either upper or lower of the double bond tu. Okay, but if you talk about trans, dia perpendicular ni melentang lah. Okay, location of the H from the carbon that has the double bond, okay, dia adalah bertentangan, okay, perpendicular. So that is the trans configuration. Okay, so for trans configuration, higher MP than cis. So ellagic has a higher melting point than oleic acid. Okay, fatty acid determine the characteristics of the fat. Okay, so what type of fatty acid yang kat dalam contohnya dalam triglyceride kan, dalam triglyceride dia ada glycerol punya backbone, macam dia punya where the fatty acid will be attached. Okay, because we call it triglyceride, so it will have three fatty acids lah, depending on what type of fatty acid that is attached on the triglyceride. That also determine the type of sama ada whether the fat will whether the lipid will be solid or liquid. Okay, fatty acid determine characteristic of the fat, because fatty acid ni dia adalah single fatty acid. We're talking about shorter chain versus longer chain, the one that has double bond versus non-double bond, saturated versus unsaturated. Okay, so basically you can see from this diagram. So the shorter carbon fatty acid most likely will be liquid at room temperature as versus to the higher chain. Okay, kalau yang macam zigzag panjang ni, that means you have more of a carbon. Okay, the longer carbon will be more solid at room temperature. Okay, But ada juga yang in the middle, for example, semi-solid. Semi-solid ni is like yang the spreadable ones too. Mostly dia macam after hydrogenation, some of the I give you example yesterday, like the olive oil, kan? When you want to make it more spreadable, so we call that like semi-solid lah. So bila kita keluarkan dia, dia macam a bit of oily, but you can spread it. It looks like macam exactly macam spread lah. Okay, and when you bring it out from the fridge, at certain time they will become oily. They become oily. Okay. So short chain less than 6 carbon, medium chain normally this one is like at the normal situation. Normally kita panggil SCFA, short chain fatty acid, MCSA, medium chain fatty acid, and long chain fatty acid. In terms of nutrition, this short chain fatty acid, medium chain fatty acid, long chain fatty acid ni, especially the SCFA and MCFA, dia ada certain nutritional value. Dia sama macam, it is exactly like the peptides. I think when Prof taught you about proteins, okay. I think she also mentioned about some of the peptides. Dia ada it can give you the taste or the flavor, right? Macam aspartic acid, the umami taste, those are actually from peptide. The taste comes from the peptide itself. So it is the same as fatty acid, because fatty acid is a series of carbon chain length. Okay, so some of the SCFA and MCFA, short chain and medium chain, it will give nutritional attributes, to health actually. Okay, so the shorter the carbon chain, the more liquid the fatty acid is lah. Just tengok dekat gambar ni, dekat diagram ni. Okay, so this one is the just to show the table of greater number of double bond. Okay, so the greater number of double bond, fatty acid molecule are more bend. Okay, more bend meaning that dia tak jadi straight, because of how the nature of the molecule is. It tends to be more bend because when we learn about chemistry of structure molecule, dia ada banyak, it has a lot of bonds that is involved. We have hydrogen bond, we have van der Waals bond, we have apa lagi? Kalau dalam protein, we have peptide bonds, and then we have, kalau dalam kata alih aja apa, carbohydrate, we have glycosidic bonds. Kan? You have to know the difference between all these bonds. We have hydrophobic interaction, we have ionic bonds. Okay, and then lastly we have the covalent bond. Okay, but in this fatty acid, or in this fatty acid chain, okay, the longer the carbon number, okay, the fatty acid molecule tends to be more bent because the weaker van der Waals bond between the molecules. Okay. Okay, ni kita dah tengok tadi. The higher the number of the carbon, okay, like capric acid, lauric acid, myristic acid, palmitic acid, stearic acid, okay, the higher the melting point, the one that have 0. Yesterday we have done this part. And then for oleic and elydic, okay, both also is 18.1, and the location of the double bond is at 9. Okay, 9 carbon 9 starting from the methyl side. But you can see that although both oleic and elydic ni, they have the same number of carbon and the unsaturation, okay, but the difference between the melting point are very quite clear. Okay, so one oleic acid is 13. So 13, if at room temperature, dia adalah apa? Dia adalah oil lah, because our room temperature is about 30 degrees kan. So for elydic, at room temperature dia masih lagi belum map. So at 36 kan. Because the location of the one is cis, one is trans. Because elydic ni dia trans octadecanoic acid. Okay. If they happen in a triglyceride form, triglyceride meaning that there will be 3 fatty acids in the backbone. Okay. Glycerol backbone. You can see that the MP for this triglyceride will be even more significant. No? One is 5, one is 42. Okay. So kena tengok juga, although you see that the number of carbon is the same, the number of unsaturation is the same, but one is cis, one is trans. So trans will have a higher MP than the cis. Okay. Okay, why does different fatty acid have different molecular weight? Melting point. Okay, why different fatty acid will have different melting point? Okay, tadi we talk about the bond, kan? Okay, we talk about the bond. Okay, why? Because you see all these carbon hydrogen bond. Okay, kan? Kita belajar hydrogen bond since we learn about water, kan? Water have this hydrogen bond, yang partial hydrogen bond. Remember the structure of water, the one that you have the 1H and 2 oxygen, kan? Because of the degree location, dia macam looks like a Mickey Mouse, right? Mickey Mouse ear. So it's not exactly 90 degrees. Dia about macam triangle. So because of that, dia ada partial bond lah, partial hydrogen bond between O and also the H. Okay, this one also almost the same. So why different fatty acid have different melting point? Okay, because how mostly how saturated the chemical bonds in the fat molecule are in hydrogen atom. Okay, so because remember when we have carbon, the number of bonding in carbon is always 4, and it's either it will bind to double bond with another C, and the rest will be either methyl or H lah. Normally the structure of molecule is like that. But for fatty acid, okay, the other bond other than carbon will be H. Okay, so that is the hydrogen bond between the hydrogen and the carbon. Right? Mostly how saturated the chemical bond in the fat molecule are in hydrogen atom. So the more hydrogen atom a fatty acid has, so the more hydrogen atom, meaning that the longer the C, because the one that complete the bond of the C is with hydrogen, kan? Kalau kita lukis, if we write, if you take a pencil and write C, the others, if they are not combined with other R group or amine group, is always the H. Okay, so the longer the C, the more hydrogen bond a fatty acid will have lah. Okay, so the more hydrogen atom a fatty acid has, the more saturated it is. Okay, then the higher its melting point will be because of the sekarang kita fikirkan kenapa, why is it that a different fatty acid will have different MP? Because of that reason. Okay, so you see here the hydrogen bond on the opposite side ni, hydrogen bond ni, hydrogen bond are the bond between hydrogen and other molecule, other carbon. Okay, mostly dia attach because hydrogen dia ada satu bond saja, so dia akan normally attach with either oxygen, nitrogen, or carbon. Okay, in this case, dia carbon lah. Okay, hydrogen bond on opposite side of the carbon of the chain of the carbon double bond. Okay, because of the hydrogen bond. Okay. Okay, packaging of the fatty acid. Okay, tadi we talk about how trans configuration a higher melting point than cis configuration. Okay, if we see here, and this one is just now we have looked at the how it is written, kan? Okay, if you see here, kat sini kan, kita tengok ni 81 omega 9, 81 omega 9. Okay. So if you actually calculate this, these are all 18 carbon lah. Okay. So this is the omega-9. This is also omega-9. But for the oleic acid, the location of the H is at the same location. Okay. Same location meaning that dia selari lah, dia same location. So that is oleic. So bila oleic, dia cis, dia adalah the melting point will be lower. So tengok kat sini, it is 5 degrees C. Kalau dia dalam bentuk ni lah. Okay, kat sini kan. Kita tengok kat sini. Okay, if it is in triglyceride form. But for elidic acid, it is dia bertentangan, okay, trans. So it is actually perpendicular, the location of the H. So you can actually see that it directly increase the melting point from 5 to 44. So the higher melting point for straight chain fatty acid than branch fatty acid, higher melting point for TAG with more symmetrical distribution of fatty acid on glycerol molecule. Symmetrical distribution ni meaning that dia punya SN1 to 3 ni dia almost the same fatty acid. Kan? We're talking about single fatty acid, tapi in oil the composition of fatty acid is actually it is in terms of triglyceride or triacylglycerol. Okay, so the location or at the SN1 to 3 of this, if they are more symmetrical, the higher MP for TAG. Okay. So molecular configuration of TAG, the molecular configuration of triacylglycerol can also affect the properties of fats and oil. Kalau macam ni, dia triacylglycerol is a turning fork structure. Turning fork structure ni, contoh dia punya location of the SN2 ni is the other way around. Dia tak necessarily located symmetrically at on the right side, for example. Okay, variety of structural organization, solid and liquid state. Okay, this is actually quite important when we study lipid, okay, of fats and oil. When we study lipid, actually, yesterday I mentioned, right, when we see from our naked eye, we see that it is oil and also liquid, oil and also solid, right? But if we see the molecules of the fat under microscope, you can actually see fat ni dia ada kristal dia dalam fat molecule tu. Okay, but the crystal normally happen, there are 3 types of crystal, alpha, beta and beta prime. Okay, nanti kita tengok later. So the crystal arrangement ni, okay, in the fat, that actually gives the characteristic of the fat itself. Okay, depending on the molecular characteristic, okay, chain length tadi kita already mentioned the chain length in terms of carbon number, okay, and then degree of saturation and also polarity. Polarity ni if they are more higher carbon, then it will be more less polar, more hydrophobic or more saturated lah. Okay. Okay, that one, the crystallization tu, in fact, we call it polymorphism. Okay, so kalau if we learn about fats and oil, we cannot run away from this term polymorphism. Polymorph, kita panggil dia fat polymorphs. Okay, it is actually crystal. What type of crystal form of fat you are talking? You are referring to. Okay, so this fatty acid chain tend to tak apa, nanti kalau habis saya start balik Saya rasa saya pakai yang free version pun ini. Okay, never mind. Fatty acid chain tend to orient and align and maintain its orientation as temperature is decreased below the melting point. So fatty acid tend to orient and align, meaning that dia akan oriented itself lah, fatty acid chain ni, and to maintain this orientation, okay, as the temperature is decreased below the melting point. So by doing that, the crystal will form at the fat or the fatty acid lah. Okay, the type of crystal that form depend on the molecular structure and composition of lipid. Bila kita tengok composition of lipid ni, meaning that what type of fatty acid does the lipid has. Okay, tadi we talking about SN123, right? So you can have a mixture of fatty acid in that lipid that is actually give you the composition of that particular lipid. Cooling rate, macam tadi kan, dia kata temperature is decreased. So cooling rate tu meaning that how fast or how slow the cooling rate from, for example, from high temperature to low temperature. Okay, that also will give the crystal formation. Okay, and presence of nuclei. Okay, kalau ada presence of nuclei ni, dia macam ada starting material untuk dia form form crystal. Okay, so the presence of nuclei ni when it present, okay, the nuclei present, dia akan quickly form the crystal, okay, because of that particular nuclei. Okay, holding temperature is actually some fat bila dia when they change the formation tu, they will be whole at certain temperature for certain period of time. Okay, and then we have to see holding temperature ni, what are the holding temperature is being used, then that also can form a crystal during that holding time. No? And also the shearing, what type of shearing that is given in the treatment of the fat changes. Okay, cooling liquid oil ni, rapid versus slow rate will produce small crystal versus large crystal. Okay, and also the solid solution will have the homogeneous crystal versus mixed crystal. Mixed crystal ni will have heterogeneous crystal, meaning that kan tadi crystal, I said there are 3 types of crystal. Later we will see macam mana dia punya packaging of the crystal. One is alpha, one is beta, one is beta prime. So kalau the crystal form, they are all the same, like alpha crystal or beta prime crystal. So they are homogeneous crystal, like solid solution. But if this crystal are mixed crystals, okay, between alpha, beta, and beta prime, so they are called heterogeneous. Okay, so these are mixed crystals lah. We call it mixed crystal. Okay, depending on the cooling of the liquid oil. Okay, so this is the crystallization of lipid. If you can see here, ni dia punya, this one is taken from one of the textbook lah. Okay, physical state ni, physical state, and when you actually see under the microscope, you can actually see the formation, the liquid formation or the crystals. They look like this. You can actually see the mixture of crystals. Okay. If you go to this one, we cannot see in the normal microscope. We have to see using scanning electron lah, yang higher magnification. Okay. So for liquid, you mostly see that the dispersion of the molecule are more smaller. Okay. For example, frying oil, biofuel, or lubricant. So this one will be good for the functionality of heat transfer. Because dia liquid kan, kita boleh, maksudnya kalau kita heat the oil, dia akan jadi a good medium for the heat transfer lah. Okay. Viscosity, okay, for viscosity, maksudnya kalau in food molecule, in food component of food system, when we add the oil, so it can become more smooth, more smooth, and also oxidation stability. Oxidation stability in terms of the stability of the liquid lah. Liquid oil. Okay, and then sometimes you see this physical state, kita panggil dia bulk physical state. And then if you see under microscope, you can actually see the mixture, the heterogeneous mixture crystals of the molecule tu. Okay, this one kita banyak jumpa ni kat dalam coklat. So if you actually take the chocolate and then you put it on the slide, okay, and then you see under microscope, you can actually see a mixture like this. and also hard lipstick. Actually lipstick tu buat banyak menggunakan fats lah, fats and oil kan. Masa buat lipstick tu dia kena letak dia punya fat component. Okay. And then typical functionality for this type of physical state, for hardness, sharp melting point, and also for crispy touch. Okay. And then we also have gel. Okay, gel ni, okay, gel type physical state. Okay, typical products will be water barrier film. Okay, and also soft lipstick. Kan kita ada hard lipstick dengan soft lipstick kan. Okay, itu dia dalam bentuk in terms of gel format, gel punya physical state. Okay, so this one is good for oil binding property, for spreadability. This one yang I kata yang bila kita buat spread, yang bread spread tu kan. So dia boleh easily spread on your bread lah. Okay, hardness and also softness. Sebab dia kita panggil dia semi-solid. Semi-solid punya formation. And then we have emulsion. Emulsion ni apa maksud dia? It's a mixture, right? Emulsion ni dia macam is a mixture of water and oil. So it's either oil in water, OW, or water in oil, WO. Okay, nanti kalau maybe when you do your FYP project, when you learn, when you read in newspaper ke artikel kat mana scientific terms, you will see sometimes it is written as OW and WO. So it means that is actually an emulsion, water in oil or oil in water. Okay, meaning that kalau macam ni, dia water in oil lah, dia oil in water. Okay, meaning that the medium is actually water and then the droplet is actually the oil. Oil in water emulsion. So this one, emulsion ni normally dia tak mix lah because oil and water doesn't mix, right? So what we need to do to make it a good emulsion, kita guna emulsifier. There are so many types of emulsifier. Can be protein, can be fat. So nanti kalau, for example, you buy products in the market, like you like to eat burger for example kan, kita ada yogurt, we also have dalam burger kita selalu guna apa, mayonnaise. That is a very good emulsion lah. So you see a good mayonnaise will not separate if you keep it at room temperature, if you keep it in the fridge kan, dia tak separate the water and oil tu. Okay, for yogurt also is the same, kita guna stabilizer, we use emulsifier. Okay, so when you buy this kind of products, try to read, dalam coklat also we use emulsifier kan. Kalau tak nanti coklat tu tak cantik lah dia punya physical characteristic, physical appearance of the chocolate. So you have to use emulsifier in for the food that has a mixture of water and also oil. Okay, so we use stabilizer, we can use emulsifier. Normally the manufacturer will write it in terms of the name of the emulsifier. Sometimes they use the E number tu. Okay, nanti masa we do the additive, kita tengok what type of E number represent emulsifier. Okay, normally they use 471, I think the number 322 471. That one is 471 is the soy lecithin lah. Soy lecithin is being used a lot in food system lah as an emulsifier. Okay, so emulsion can be good functionality for spread, texture and stability. Okay, and then another one is foam. So we have foam ni macam whipped cream, ice cream. Okay, that one is good for dispersibility, stability and thermal conductivity. Okay, I have less than 1 minute. I think the Zoom will close. I will start again. Okay, sekejap Okay, you all kena masuk balik tau. Sekejap I share balik. Okay, I will